Alright, peeps, today we're going to talk about how to add and subtract rational expressions. So step number one, we're going to rewrite the problem and make sure that it has a common denominator. So we have two fractions here, has to have the same denominator, right? The denominator is on the bottom, has to be the same. If it's not, we need to make a common denominator. If it is, like number one, then we're going to combine the numerators, keep the denominator the same, and then we'll simplify. So the same way we do with adding fractions, we need to make sure they have the same denominator, add the tops, the bottom stays the same. So in this case, my denominator is 4a squared. I'm going to add these two on top, so combine like terms, 13 and 5, it's going to give me 18a. Now we're going to use our exponent rules to simplify this expression. So that cancels out with that. This can be reduced by 2. So we get 9 over 2a. Bam. Same thing with number 2. Number 2, my denominator is 16, so we have the same thing. Alright, so now we can combine these two together. So 9x minus 7x is going to give me 2x. 12 minus 2 is going to give me a positive 10. Now, both of these or all three of these, I guess you would say, are all divisible by 2. So we can reduce everything by 2. So it's going to become x plus 5 over 8. Looking at number 3. Number 3, again, same denominator, y squared minus 9. So let's go ahead and put that in the denominator. On the top, we've got y squared, no more y squareds. We've got 8y and 2y. It's going to give me 10y, and then plus 21. All right, now, I can factor this. Factors of 21 that add to give me 10 are going to be 3 and 7. On the bottom, I've got y squared minus 9. That's perfect squares, so y minus 3 and y plus 3. Now we're going to reduce, right? I have y plus 3 on the top, y plus 3 on the bottom. Let's get rid of it. So on the top, we're left with y plus 7. On the bottom, we're left with y minus 3. Looking at number 4, my denominator is 12a minus 3. On my top, I've got 1 minus 16a squared. Now let's look to factor if we can. This is the difference of two squares, so we get 1 minus 4a and 1 plus 4a. On the bottom, I can factor out a GCF of negative 3, and that's going to become negative 4a plus 1. Alright, so here we go, negative 4a plus 1, negative 4a plus 1, bye-bye. On the top, we're left with 1 plus 4a. On the bottom, we're left with negative 3. Looking at number 5. Number 5, my denominator is n squared plus n minus 6. On the top, I've got n squared, no more n squareds. I've got 3n minus n is going to give me positive 2n. Negative 7 minus 1 is going to give me a negative 8. Alright, so now we're going to factor the top, factor the bottom. So we're looking at factors that multiply to give me a negative 8, but add to give me 2. So it's going to be n plus 4, n minus 2. On the bottom, I've got n squared plus n minus 6, so we're looking at factors of negative 6 that add to give me 3, n plus 3, n minus 2. Bye-bye. On the top, we've got n plus 4. On the bottom, we've got n plus 3. All right, moving right along, looking at number 6. Okay, number 6, same denominator, so we got 6k squared minus 5k plus 1. On the top, we've got 13k squared plus k squared is going to give me a 14k squared. Negative 9 plus 2 is going to give me a negative 7k. Now let's look to factor this. So I have a GCF in the top, so I can factor out my GCF of 7k. So let's take 7k out. We get 2k minus 1. On the bottom, we're going to factor this, so looking at our asterisk method, in the top goes 6k, 6k. We're looking for factors that multiply to give me 6, but combine to give me negative 5. So it's got to be negative 3 and negative 2. We can reduce this fraction by 3. It's going to give me 2k minus 1. Reduce this fraction by 2. It's going to give me 3k minus 2. Alright, so on the bottom we've got 3k minus 2 and 2k minus 1. Now, same thing. Bye-bye, Felicia. Alright, so this is going to give me 7k over 3k minus 2. Alright, now number 7 and number 8. Notice that we do not have a common denominator. Alright, so we need to find our common denominator. So I need to make this the same, right? So 2x, this is 3x. They both have an x in it, so we don't need to multiply by a variable. But we need to get the same number here. So we're going to take this one, we're going to multiply it by 3 We're going to take this, we're going to multiply it by 2. So it's going to become 45 over 6x minus, this is going to become 32 over 6x. Now we have the same denominator, so we can say, okay, that's equal to 45 minus 32 is 13 over 6x. Now we can reduce that if possible. It's not possible to reduce, so there it is. Same thing with number 8. Now number 8, this has a coefficient of 8, this has a coefficient of 1, so we know we need to multiply this by 8. This is going to give me 8a squared. So we need to make this 8a squared. So I need to multiply this by the variable a. So 8a squared here. This is going to give me 32a minus 7a over 8a squared. So now we have the same denominator, 8a squared. And we're going to subtract 32 minus 7a. It's going to give me 25a. Alright, now we can use our exponent rules and reduce. That goes away with that. So we get 25 over 8a.